Hey guys, first we'll see if it processing or not. Yes, it is still processing. So let's talk about general pathology. First, cellular response to the injury. We are starting from the basic. I mean, in the biology part, in the physiology, all the basics, how normal physiology works. We have seen that cell is a unit of all the live organisms, or some organisms are just unicellular. So cell is a basic functional unit that is operating at the very basic level to form all the living structures. We know that how living organisms are defined, that they are very complex organism made up of all the organic molecules like protein, carbohydrate and fatty acid. They are macromolecules that are helping in the structure and complex reaction to produce energy and to help the organism to functional to be functional and do its work and maintaining the liveliness. What do you mean by the liveliness is to pass down the genomic sequence and continue this. Liveliness means complex reaction of cycle and producing the energy and doing this repetitive work again and again. So this is we defined as the basic definition of how we are calling the living organisms. And as the complexity increases, the works are gonna increase. So at the human level, we are the most advanced species on the earth, and we are doing very complex reactions at mental levels, at the physical level, all the motors, fine scale task, the gross scale task, and we are doing the mental function like complex calculation, the logical and analytical ability to understand deep things. And we are aware interpersonally as well as intrapersonally, and we are uh, able to um, understand what is going actually around us and what is happening within us. So this consciousness is gifted to mainly the mankind, and complex all the complex reactions that our body is doing to maintain this task, this mental and physical one, as well as the reproductive, to keep this thing going on, is what we call our complex liveliness. So we are learning this complex thing about our body. So first we have understood the basic difference between living and non-living thing, and what are the functions they are doing at very basic level, that is called as the cell. And then at the complex level, at human being, there are various system divided to do this function. So we know that at all the system level how it is working mainly. And that's why in medical science of human, we have to understand at the molecular level, that is the biochemistry. Then we have to understand all the system wise approach. So first we have to learn the structure, then the normal function, that is physiology, and the pathology part. Then we are doing all the treatment modifications by either surgically or by at the molecular level. So we have to learn the surgery, the medicine, and all the other system wise science, that is the derivative of this just concept. So in the pathology part, we have to first learn at the basic level, at the cellular pathology, what are the injuries that is damaging our basic unit, that is called the cell. So any injury you can name it, either the physical one like radiation or trauma or burns, that is due to higher temperature, or the opposite one due to lower temperature. So any injury that is either physical or chemical injury due to any toxins or drugs or any toxic metabolites also, or any infectious agent that is destroying either virus, bacteria, fungus, parasite, and you name it, all the infectious agent that is available in the environment, or it can be our body itself also, in the name of autoimmunity. So all these things collectively destroying this basic functional unit called as the cell. So how this cell is adapting and what are the harmful effects it is going, we have to learn the pathology part, that when any injury, when any disruption from the normal happens, how the cell is going to reply. So first cell will try to do the adaptation. And I forget to tell you, the main most common injury is the hypoxia. What is the difference between hypoxia and ischemia? Hypoxia is the lack of oxygen just at the cellular level, but ischemia is lack of total blood supply. So all the nutritional flow to the cells along with oxygen is going to hamper, as well as the toxic metabolite clearance will be affected too. So first cell will try to adapt if the injury is still persistent, and if the cell is not able to adapt further, it is going to create the reversible cell injury. Till now the cell is still able to revive to be a normal and can normal if the injurious agent is removed quickly. If not, then it will go into the reversible cell injury, and from this cell can't be normal. The only destination is the death of the cell, and this we call as the necrosis. So now we are going to learn about this step by step. What is the adaptation, what is reversible cell injury, what is irreversible cell injury, and what is type of necrosis. So first we will learn the adaptation. In adaptation there is atrophy, hypertrophy, hypoplasia, and metaplasia. So quickly I am going to tell you this, not going to write. So in atrophy, what is happening at the molecular level? Mechanism is there is a reduction in the cell size or cell count, and why the cell size is decreasing is because of the cellular organelles is going to reduce. And how we are going to do this mechanism is by ubiquitin mediated proteolysis. So ubiquitin mediated proteolysis is happening, and in this what will happen, this autophagic vacuole formation will happen. So all the organelle we want to destroy, what will we do? We will convert the organelle into a membrane bound structure and fuse it to the lysosome, and this is called as the autophagic vacuole formation, and the organelle will be destroyed by the lysosomal enzyme. So this process is we known as ubiquitin mediated proteolysis. So in atrophy you just have to remember this word, that organelle destruction is happening by autophagic vacuole formation, and it is a ubiquitin mediated proteolysis. Okay. Now, what are the example of this? Why actually it is happening, and what is the injuries that is causing this kind of adaptation? So this kind of adaptation we'll see when there is any hampering of the blood supply or nerve supply in the muscles. So it can be nutritional atrophy due to protein energy malnutrition, and proper nutrition is not going to the cell, so this cell is adapting this way, or either there is uh, ischemic atrophy, blood supply is not going, so it will be same as the nutritional one. And the example of this ischemic atrophy can be atherosclerosis or thromboanginitis obliterans. Then denervation. Now nerve supply is not there either in hemiplegia or paraplegia, and the muscle has no use, it will be paralyzed, so the muscle atrophy will happen. And the same thing will happen when we don't use the muscle. So disuse atrophy in the immobilized limb, either it can be due to fracture or it can be any other thing. And then last one is due to pressure atrophy, like pressure due to tumors, the blood supply is not going there properly. Now one example of this autophagic vacuole formation is what will happen in the old age. There will be uncleared autophagic vacuoles in the cell. So in the old age there will be uncleared autophagic vacuoles will be there, and this is known as the lipofuscin. I don't know, I have read that it is due to the lipid peroxidation, the free radical mediated damage, this lipid will accumulate, and this is known as lipofuscin. And here it is due to unclear autophagic vacuoles. I mean the mechanism can be both also, like there is lipid peroxidation which is happening due to free radical mediated damage, and this lipid is not getting cleared, and that is accumulated as a lipofuscin. Is this a brown color pigment? And you have to know the other names also, like it is known as the wear and tear pigment or the aging pigment. And this process is known as the brown atrophy, and the main accumulation site is the paranuclear one, and mainly seen in the myocardial of old people, and we can do age estimation by this pigment also. And yes, this is not going to harm the cell in any way, it is just a sign of aging, or it can be due to the endocrine, yes, endocrine hormonal inhibition. So what will happen after menopause? Postmenopausal female will experience the atrophy of the all or reproductive hormone that is mainly maintained by the reproductive hormones. So breast, uterus and ovarian and vaginal atrophy will happen after the menopause. Now the stain here will be the Sudan black due to lipid. So staining we can do by Sudan black. Now hypertrophy. We are going to discuss about the hypertrophy. It is exactly opposite that of the atrophy that we have discussed till now. It is increase in organ size, and why organ size is increasing? Due to increase in the cell size. And why cell size is increases? Due to increase in the organelles. And what are the injurious agent that is causing this? Is exactly opposite that of the atrophy. So increase workload or increase stimulation will do the mainly muscle atrophy. Muscle will go the hypertrophy. Muscle mainly will go to the hypertrophy. We have to discuss the three muscle: cardiac, skeletal and smooth muscle. And the example in hypertension or any valvular disease, there will be hypertrophy in skeletal muscle due to exercise, and in smooth muscle mainly the pregnant uterus, or it can be due to hormonal also, like in the breast, lactation and pregnancy. Now the hyperplasia. So hyperplasia is increase in organ size due to increase in the cell number. Okay. And hyperplasia is always defined as a microscopically. And here what will be the examples? So and the cell numbers are increased mainly by the cell who is able to divide. So mainly there will be epithelial hyperplasia. And what will be the reason? So first we will talk about the hormonal thing. Due to high estrogen there will be endometrial hyperplasia. And due to increased testosterone there will be BPH, that is benign prostatic hyperplasia. And there is now glands also. So glands of breast, the example is puberty and pregnancy. And in gland also the bronchial glands due to chronic bronchitis. Also the smooth muscle interestingly can go hypoplasia, and here the example is pregnant uterus. And the last example is erythroid hypoplasia that will occur in the high altitude. Now how will you exactly going to remember the hypertrophy and hypoplasia example? So as we have remembered, in the atrophy it will happen when we are not using any organ. So denervation injury or disuse atrophy, we are not using the muscle, that's why mainly it is going into the atrophy. As well as if we don't give enough hormonal stimulus or enough nutrition. So in hormone we know that it will happen after the post menopause, and in the nutrition we know that it is nutritional. So protein energy malnutrition or it can be due to ischemia or pressure atrophy. So all these things, so either the nutrition is not going there, stimulus is not going there, or we are not using, then the atrophy will happen. So it is logical. When will the hypertrophy will happen? Hypertrophy and hypoplasia, either hormonal stimulus is too much. So when will hormonal stimulus will increase? We know that in pregnancy, puberty, and in male also due to testosterone, but we will discuss first. We will learn about the puberty and pregnancy part. In puberty there will be hormonal surge. So in breast what will happen? There is hypoplasia, and yes, just hypoplasia, not hypertrophy. And while pregnancy there will be both in breast hypoplasia as well as hypertrophy. In lactation just the hypoplasia, means increase in size of the gland will happen. Hypertrophy. So this we pregnancy related to the breast we have to remember, where we see the hypertrophy and hypoplasia. While in uterus during pregnancy both will happen. Smooth muscle are able to divide also, able to increase the size also. So hypertrophy and hypoplasia both will happen. So now we know The hormonal example during the puberty in the breast and pregnancy in breast and uterus both. While in male, the hypoplasia will happen in the prostate epithelium. Also, due to increase in estrogen not related to the puberty or pregnancy, but the epithelial lining will go to the hypoplasia. So this is also an example of the hyperplasia. Wait, so this we have to remember that due to hormonal, this is all hormonal, endometrial hyperplasia, BPH, breast in puberty and pregnancy, as well as the smooth muscle of pregnant uterus. This is due to all the hormonal. And here also the hormonal will be the breast, here also the pregnant uterus. Now, increased workload mainly seen at the skeletal and cardiac muscle level. What will happen? There will be mainly hypertrophy only. And if there is increased demand of RBC, erythroid hyperplasia will happen, and this one bronchial gland will go hypoplasia in chronic bronchitis. This is a different example. It is not due to any hormonal stimulus or due to increased workload, but mainly the pathological part. Okay, so this we have to remember. I mean, this is also pathological, endometrial hypoplasia and BPH also. All other things are, I think, normal physiological thing. Cardiac hypertrophy is again also pathological one. And now the last point is about the metaplasia. What will happen in the metaplasia? There is one mature cell form is replaced by the other due to increase in any increase, or you can say change of the function due to any injurious agent that is happening repetitively. Like we know in the smoking, due to smoking, the stratified squamous epithelium not stratified squamous, pseudo stratified ciliated columnar epithelium will be replaced by the stratified squamous epithelium if we are due to smoking, pollution or vitamin A deficiency. So this is known as the squamous metaplasia, and it is the most common type of metaplasia. Example is the respiratory tract, most common side. Then the second one is the columnar metaplasia. And when will columnar metaplasia happen? In the esophagus stratified squamous epithelium, due to acid reflux, the converting into the intestinal type of columnar epithelium, and the goblet cell will be seen here. Also, one other example is cervical metaplasia, in which the endocervix lining is normally the columnar epithelium, and due to chronic inflammation it is converted into the squamous epithelium. So endocervix also in this category also. And the third one is slightly different. In thyroid gland, generally the cuboidal cell are converted into the oncocyte, also known as the Hurthal cell, in the Hashimoto's thyroiditis. Now there is slightly different one is the mesenchymal metaplasia, in which all the classification is totally different. So the skeletal muscle, which is a connective tissue, muscular tissue, is converted into the connective tissue, which is a bone. and it is due to physical injury, repetitive physical injury like horse rider or boxer. So the example is myositis ossificans. And all metaplasias are pre-malignant condition in nature. Now we are learning the reversible and irreversible cell injury. What will happen in the reversible cell injury? There will be hypoxia or ischemia, so the ATP formation will be decreased. So what will happen? First, the ATPase pump will not able to work, that is Na plus K plus. So sodium won't go outside and potassium won't come inside, failure of the sodium potassium pump, and that's why there will be water accumulation as well as sodium accumulation in the cell. So cell swelling will be the earliest feature, then the membrane blebs will be formed, swelling of organelles, there will be vacuoles in the cytoplasm, detachment of the ribosome, and there will be myelin figures in the reversible as well as irreversible cell injury. Now due to decreased oxidative phosphorylation, cell will switch to the anaerobic glycolysis and there will be increased lactic acid. So increase in pH will cause chromatin clumping, that is just focal darkening of the DNA. Now the irreversible injury, there is failing of two more pump, that is calcium and H plus. What will happen due to failure of the calcium pump? There will be so much accumulation of calcium in the cell and this will cause increase in intracellular calcium that will get deposited into the mitochondria due to increased permeability of the inner mitochondrial membrane, and this is called as the amorphous densities, and this can be only seen under the electron microscope, and this is a type of dystrophic calcification. Now due to H plus pump getting not working, H plus will also get retained in the cell and this will cause further decrease in the pH. So this will decrease in pH, further will cause chromatin condensation and there will be feature of the pycnosis. Now this H plus and calcium both will cause the lysosomal enzyme activation, and there will be lysosomal enzyme like phospholipase, protease and RNase. So phospholipase will cause cell membrane damage, leakage of the intracellular organ content into blood. So increase in blood markers, that is cellular enzyme or proteins. Example is increased troponin in irreversible cell injury. Now protease and RNase will cause proteolysis and RNA lysis. Eosinophilia of the cytoplasm will happen, and due to endonuclease DNase, there will be chromatin fragmentation known as karyoregesis and chromatin dissolution, that is karyolysis. So this thing will happen. And now there is a free radical injury. So in free radical injury, what will happen? We have to learn some equations. So let's see. Now let's first talk about what are the free radicals. So free radicals are mainly the molecules that contain single unpaired electron. And due to this, they are highly oxidizing agents, so they just want to take another electron, so there will be paired electron formation can be happen. And mostly it will be derived from the oxygen. That's why they are also known as reactive oxygen species. And how exactly they are form. So let's learn the reactions. The first one is the superoxide ion formation. It is due to incomplete reduction of the oxygen. This is known as the superoxide anion. Second one is the Fenton reaction. What will happen? This transitional metal like iron and copper will give rise to the OH minus. And how exactly this reaction will happen? So will convert into plus 3 plus OH minus, and this one is the most potent free radical. I have actually kept a pic. Let me see if I can find one of the oxidation. So this one was, I think, yes, due to Fenton reaction OH minus ion, and no, this is not it. Yeah, this was it. So I am explaining this one how is exactly. So by O2 we are deriving the superoxide anion, and from the superoxide anion, due to the enzyme superoxide this mutase. This is going to convert into the H2O2, and we can either go into formation of H2O so that there won't be any free radical damage either by catalyzed enzyme or glutathione peroxidase system. In both this way, glutathione peroxidase will also convert the H2O2 into H2O, and here as so how this is how it is going to convert H2O2 into H2O. Let's see. So glutathione peroxidase will convert H2O2 into H2O, and this glutathione will be oxidized. So glutathione GSH, glutathione peroxidase will convert the glutathione into its oxidized form, and glutathione reductase will again convert it to its reduced form. And in this reaction, NADPH will be used, that is will be formed by G6PD, hexose monophosphate shunt pathway. And this can go either way. By H2O2 we can form OH minus via Fenton reaction, and this will cause damage to the lipid, DNA and protein. So misfolding of protein will happen, death of cell, DNA mutation will happen, and lipid peroxidation will happen, and it is a most sensitive one. And due to lipid peroxidation, cell membrane damage will happen, and this is irreversible damage. So this is most sensitive. Here it will be mutations and misfolding of protein. Either way it will going to lead to cell death due to irreversible damage. So DNA mutation, misfolding of protein and lipid peroxidation will cause cell membrane damage. Okay, now this OH minus will also form, and we can also form O2 by NADPH oxidase also. NADPH oxidase will form this superoxide ion, and then it will convert into H2O2, and this H2O2 will combine into with chloride and form myeloperoxidase. Enzyme will form OHCl minus, and this will help to kill the bacteria. And in scavenging there is also like antioxidants are there. There are vitamins like A, C, E, and selenium, zinc and molybdenum. Antioxidant. And in protein we know that it is transferrin, which is bind to iron, ferritin and ceruloplasmin. So this two iron and this one copper. So this free radical is useful in bacterial killing, but they will also do them damage by premature aging also, and cell death and reperfusion injury. And how exactly this is going to happen? So cell injury after reperfusion of a hypoxic tissue, there will be increased oxygen reaching to the tissue will be converted into superoxide ion, and it can lead to cell death, or it can either be due to increased inflammatory mediators and calcium, and it will be determined by the type of cell as well as duration of hypoxia.